Hi guys, so in this video we'll take a look at problem which is related to Trie data structure. Now Trie data structure is a quite unique data structure in a way that it's not commonly used, like especially in colleges and courses. We come across data structures like stack, linked list, queue, array, and we don't come across Trie much. So that's one point. And then other is if we are interviewing for companies like Fang and all that, then they expect us to know the Trie data structures. So that's why it's kind of special or kind of different from other data structures. And if you're interested in knowing what are the real world usage of Trie, then applications like autocomplete or spell checker or few kind of word games, they really like Trie data structures and they really use that. So having said that, today we'll be looking at problem design, add and search word data structure. So this obviously just says that use Trie data structure. In real interview will not be told like, okay, use Trie data structure and solve this. So just keep that in mind. So one more thing about this problem is this is really popular in Facebook interviews and Amazon interviews, more so in Facebook interviews. And I'll tell you a secret. This problem was actually asked to me in my Amazon interviews. So let's look at the problem description and then we'll see how this data structure works and how we can use it to solve this problem. Okay, so this is the actual problem description. In this problem, they're asking us to design a class word dictionary, and this class just has two methods, add word and search word. So let's look at this example. So in this example, they're calling add word 3 times. So bad, dad and mad, those are add word calls, and then 4 search calls. Obviously search for pad would return false because it doesn't exist. Search for bad would return true. So this is simple, but the actual complex part is in the search word, they can give us dot. Now, if you know regular expression, dot can match any word. So that's the complex part, and that's where Trie data structure shines out. Now, search for .ad will return true because that can match any of the 3 words. Remember, dot can match any letter and ad will match ad. And then search for b dot dot should return true because that can match bad, bad. So that's the whole problem. So what we'll do is we'll understand how we can design Trie data structure and then we'll try to implement in code. Okay, so before going into solving this problem, let's first take a look at the Trie definition. So a typical Trie definition or class would have children array. So that'll be like in case of lowercase characters, we'll have 26 characters. So we'll have a children array of 26. And then we'll have a marker to say that this is the end of the word kind of thing. So in this case, we have a boolean. Now, remember that there can be variations of this class. So the basic idea would remain same, but let's say that if we have to have more characters, as in like lowercase characters, uppercase characters, or numbers, or all those things, then instead of this Trie array of 26 children, we can have a map which will have key as character and then value as the Trie data structure. So that's one variation. Now in our current problem, our search method requires us to return true. Now imagine a case where search method requires us to return a word or the list of words that match the search. So in that case, instead of this end of word marker, we'll have the string word itself at the end. So when we reach to the end of the word, we say that yes, this is the word that we matched. And then from search method, we can return that word. So that's another variation of Trie. And in fact, there is a problem on LeetCode which deals with finding XOR of all the numbers in array, and that uses Trie data structure. And in that case, the children array size will be 2 because it will be holding 1 and 0. But anyways, that problem is for some other day. Right now we'll just deal with this word problem. So now we'll actually see how our trie class performs when we start pushing words into it. So we'll take words like mad, mat, Mars, bad, and dad, and then we'll see how our trie spans out when we add those words one by one. So let's start with the word mad first. So before anything, what we do is we have our root object, which is obviously of type trie. Now it has 26 children, so 0 to 25. And now we'll take the first letter in the word mad. So what we'll do is all of them are null, and we'll go to this letter M, which is 13th character in A to Z. So we'll initialize this 13th child in the array and we'll create a new trie object at that instance. By default, our end of word is false, so we'll just keep as is. Now this will denote that we have a word with letter M in our trie. Now we'll move on to this new trie object that we just created, the children of this root object, 13 children. And in this trie object, which itself will have 26 children, will denote the letter A over here by creating new trie object at 0th position. So that'll denote that there's a letter A. And again, end of word will be false because we are at letter A. Now in this A letter or in this trie object, will denote letter D by creating new trie object at 4th position. So that'll denote that there's a letter D. So rest all the children in the arrays are null except M, A, and D over here. And in this last trie object, all the children would be null. The only thing we'll do is we'll mark end of word as true. So that'll denote that this is the end of the word mad. So if we come here while searching, return true and say that we found the word. So that's how our trie will look like if we add word mad. Okay, so now into this root object or into this trie data structure, we'll try to add second word, which is mat. So now we start with root and we say that, okay, go to this 13 children, which is M, and if it's empty, then create a new object. Otherwise, just use that. So because we added mad, there is already a trie object. So from root, we just navigate to this trie object. Now, because we already have A, we'll just navigate to this trie object instead of creating a new one. So we are repeating M and A because mad and mat, they both have M and A. So we'll keep them same. Now into this third trie object, which is the children, we already had D and we created a new trie object and we marked end of word true. Similarly for T, we'll create a new trie object and we'll mark end of word true. So for D and T, we have new trie object with end of word as true and remaining all the children are null. So that's how we'll say that, okay, this trie data structure has mad and mat. So when we search for those, we'll return true. So just like this, let's quickly add the remaining words, which are Mars, bad, and dad, and see how our complete trie data structure looks like. Okay, so this is how complete trie data structure will look like. So let's look at the Mars part first. So just like mad and mat, we already have M, so we'll just navigate to that trie object. Again, we see A, we already have that trie object, so we'll navigate to this. And now we already have a D and T, so we'll create a new object for R. Now we'll navigate to that new object trie and we'll create another new object for S. So this will again be a new trie object, and now over here we'll mark end of word as true because that's the end of Mars. Now likewise for bad and dad, we'll go to the root object, we'll create new object for B for bad, we'll go to the trie object, we'll again create a new trie object for A, we'll go to that, we'll again create a new object for D, and for that trie object we'll mark end of word as true. And similarly for dad, we'll create a new trie object for D, A, D, and then we'll mark end of word as true. So this is how we add words into trie data structure. So now let's quickly write the code for this add word method, and then we'll come back and look at the search part of it. Okay guys, so this is our code for add word. As we discussed, we have our try class with array of 26 and then boolean for end of word. And then we have add word method. In this we have our root object, which is of type try. So we always start with the root object. We mark our current as root, and then we navigate to each letter in the word. So if that letter in the current try object, or if that index in that current try object children array is null, then we create a new try object, and then we mark our current as to that index or to that children, and then we keep moving to the next character. And likewise, if we think of mad, we'll first build M, then A, then D, and then at the end we'll mark end of word as true, and likewise we'll repeat for each word. So that's how we build tree-like structure for our try data structure. So that's all about add word. Now that we know how try works and how we push words into it, we'll look at search method. And since we have already built the data structure, it's pretty easy to search in that data structure. But let's see how it works and then come back and finish the code for that also. Okay, so now with hard part of building try data structure done, we simply need to search into it. So this is the easier part. So let's see how we'll do that. So for example, let's see if we have to search mad into this try data structure. So we'll start with the root. We'll look at the 13 children, which is M. Is it initialized? Yes. So we'll go to that object. We'll look at letter A, which is 0th object. Has it been initialized? Yes. So we go to that object. Now we look at the 4th object in the children, which is D. Has it been initialized? Yes. So now after coming to this try, since our letters are done, we look at the end of word property. Is it true? Yes, that's true. And then we return true from our search method, saying that yes, mad is there in this try data structure. So let's look at a negative test case where the word doesn't exist. Let's search man in this try. So similarly, we'll start with root. We'll look at M, it exists. So we'll go to that try. Now A, it exists. We'll go to this try. And now over here, we'll try to look at N, if the try object or if that children has try object. Now we'll notice that it's null. So since that is null, we say that N doesn't exist, and we return false from our search method, saying that man doesn't exist. So that's how the negative search or the false will return. So that's simple search. Now let's look at a search with a dot word in it. So let's say if we have to find MA dot. So whether the word mad or mat, they all will qualify for MA dot. So let's see how that'll work. So we'll start same. We'll go to M, then we'll go to A, and this is our A try object. Now over here, we have finished letter M, we have finished letter A, we're at dot. Now dot means we can match any letter. Now in this case for dot, we look at all the childrens which are non-null. So in this case it will be D, R, T, and we say that all of you are valid children. So I'll go to all of those objects and try finishing my search. So we'll go to D, so MA dot, so dot matches D, and we'll go to this try object and we'll see is end of word true, because we are done with all the letters. So this will return true. So technically we can return true from our search method, but for the sake of this example, let's continue. Now for R, we'll go to this try object, and since our letters are done, we'll look at end of word property. We'll not look at S, or we'll not look at the next try, because MA dot, our letters are done. Now this end of word says false, so we'll return false from this try or from this search. And likewise for T, we go to this object, we look at end of word, it's true. So we can say that yes, mat also matches MA dot. So likewise, we can say that MAD and MAT, they both match MA dot, and MARS doesn't match MA dot. So this is how we search in our trie data structure. So let's go back, finish the search method, and then submit, and then run the code. Okay, so this is our code for search method. In the word dictionary search, we simply call the search method in the trie class, and we pass all the letters in the character array, and we pass the starting index as 0. The reason why we have character index over here is because we can recursively call the same method at different positions. So we'll see why. So we start with the current trie object and we loop through each character. So for now, let's look at simple characters. So let's think of example mad. So if we are searching for M, we'll look in the current children at the respective index. If the trie object exists, we mark our current to that trie object. If it doesn't exist, we return false, saying that this word doesn't exist. So that's a negative test case. So for simple search, mad will keep navigating to the current pointer, and once we are done with all the letters, finally at the end we look at the end of word property. If it's true, we return true. If it's false, we return false, or if it's null, then also we return false. So having said that, now let's look at the logic where dot comes in the character. So think of our example MA dot. Now we have done A, now dot comes. So in the current trie object, we look at all the children's, and for the children's that are not null, we repetitively call the search method, recursively call the search method, and we say that start looking for the next character. So dot has matched the current character, which is not null, and start looking for the next character. And if you find the complete character list, and if you're returning true, then we'll return true from this method. So that's how dot works. So that's all about the search and the add in the word dictionary using trie data structure. So let's submit the code, and let's make sure that we pass all the test cases. So there you go, we pass all the test cases with this code. So this is Java code. I also have C# code. Both the version of code are readily available for you guys. The link is there in the description box. You guys can go to the GitHub link and then take this code and run it. So that's it guys. I hope you guys understood how trie data structure works, and you guys can use it in different various applications. So if you guys like the video, give me a big thumbs up and subscribe to the channel. It really helps me out. And if you have any feedback, any suggestion, positive, negative, anything, just let me know in the comments box. I'll try to respond. And that's it guys. Keep on practicing, keep on coding, and I'll see you in next one.